So I will be tackling more about the radio access network. So this will be your foundation to understand more what is Open RAN. So if for those of you who may not know what is an Open RAN, so it is new technology that's becoming popular in the telecommunication industry over the past few years. Ayan. Okay. So moving forward, ano ba yung mga topics that we will be discussing for today? So yun nga. So we will be discussing the radio access network or the RAN. So this will be more on the introduction, some basic concepts, key principles, examples, for you to understand more about what is a radio access network. Next is, syempre, our basic or our main or the different the system, the wireless telecommunication system components. So there are different main or key parts of it. Then the electromagnetic spectrum and some of the summary of all the things that we will be discussing all throughout this session. So without further ado, I think we should start. So to start, let's have a brief overview of what a RAN is and its role in the telecommunication ecosystem. So as you can see on your screen, we have here the overview of a mobile network coverage. So um, the RAN is what we call the cell sites in layman's terms. So these are strategically placed, planned, designed across a geographic area to ensure that our mobile devices within a network coverage can connect to the RAN and the access network services. So yung RAN natin, it connects to the mobile devices, to the network, and offers mobile network coverage to us, the users. So if we take a look of a mobile coverage here on your screen as an example, it uses different color-coded system or scheme to illustrate different technologies that are present in at some certain location. So some locations still here have 2G, 3G, 4G, up to 5G technology. So, kung you observe natin, we have here a lot of 4G technology in the area. And surprisingly, we have already a lot of deployments of 5G. So, yung location and yung distribution ng mga RAN natin really plays a critical role when building or designing or planning a RAN para mabigyan tayo ng more reliable, better mobile coverage. Ayun. Nasaan? Ayan. Okay, so let's break it down. So, just like what I've said, the RAN is strategically placed to provide wireless coverage to users like us within a specific geographic area. So, the planning, the designing of these RAN components, such as the cell sites, is very critical so that the engineers, the designers, really thoroughly plan where to locate these RANs so that we, the users, have reliable, more consistent access to the network services that the network operators provide. Okay, so you can see here. Okay, here. So all over the Philippines, we have a lot of RAN deployment already. So there are already thousands of RANs that's been deployed in the Philippines, and these RANs elements create seamless coverage and mobility. So when planning the deployment of the RAN, so yung mga network operators natin really consider a lot of factors. So ito dinidiscuss ko to sa klase ko. So some of these are population density, topography, building density, different traffic patterns within an area. So if we analyze these factors, yung network operators natin determine which or where is the most optimized location and configuration of the RAN components so that as paulit-ulit, we can ensure maximum coverage and mobility. So for example, I think most of the EC is very familiar with it. So if we are deploying RAN in an urban area, so kapag nasa urban area tayo, we have a high population density, so and building density. So yung mga network operators natin deploys more cell sites with lower output power to provide coverage to small areas. So since marami nga tayong since mataas nga yung population and maraming building within the area. So kapag naman sa mga rural areas, also mas maunti yung tao doon. So yung mga network operators natin may need to deploy mas konting cell sites pero mas mataas yung output power. So mas malaki yung cover na nako-cover na area. So, I think yun yung isa sa iniisip ng mga designers and engineers natin when deploying this kind of RAN. Okay, so moving forward, so let's discuss the wireless telecommunication system. So we have three main parts for that. First is the user terminals. So ano ba yung user terminals natin? So yung user terminals natin, these are user equipments, devices that we use to connect to the radio access network. So some examples of it are smartphones, tablets, ano pa ba? Laptops and other mobile devices that is that is using or equipped with wireless connectivity features such as yung cellular, Wi-Fi, or Bluetooth. So itong user terminals natin, these are connected to the RAN via air interface. So ayun, yung radio frequency natin. So ano naman yung RAN, kagaya ng dinidiscuss ko kanina. So this is responsible for providing the wireless connectivity required para dun sa mga mobile devices natin to connect to the core network. So later on, we will discuss what is a core network. So sa core network din natin na-access yung different services that our network operators provide. So it also includes a network of cell sites, each of which has a base station that communicates with mobile devices over the airwaves. So yung different technology natin has different what we call network components. So kapag 2G base station, kapag 3G node B, kapag 4G we call it E node B, kapag 5G naman we call it G node B or the next generation node B. Ayun. So yung RAN natin, sabi nga, it connects our user terminal to the core network. So yung core network natin is connected sa RAN natin via a backhaul. So tinatawag natin tong backhaul. Yung backhaul natin, it can be a microwave, fiber optic, or copper, satellite, and other kinds of backhaul na nag-exist or naaral natin. Okay. So ano ba yung core network natin? So yung core network naman natin, this is responsible for managing the overall operation of a network. So it includes routing traffic between different networks and providing advanced services such as voice calling, messaging, and data services. Yan nga. So ito yung mga kinds of services that our network operators provide to us, the users. Again, ito yung wireless telecommunication system natin. We have the user terminals, which connects to the RAN or the radio access networks via air interface. And the RAN connects to the core network via a backhaul. Ayun. Okay, moving forward, we have what we call the electromagnetic spectrum. So we are very familiar with this, right? So so we have these are things that we use every day. So kung gumagamit kayo ng microwave, TV, radio, so itong electromagnetic spectrum na to, lagi natin itong ginagamit. And yung spectrum is we use it we call the we call this the electromagnetic waves or the electromagnetic waves. And yung electromagnetic waves natin is ranging from 300 kilohertz to the smallest, like 3 to the 10 to the 26 power hertz, something like that. So um these are other this visible light can be subdivided by color. So it ranges from lowest frequency, ito yung red. This is the lowest frequency, and moving to the highest frequency, which is colored as violet. Ayan. So others is that itong electromagnetics na to is licenses are normally 10 to 20 years in duration pagdating sa mga operators natin. Ayan. Later discuss din natin yan. Okay. So there are different cellular frequencies that are existing here in the Philippines. So we have 450 megahertz, 700 megahertz, 850 megahertz, 900 megahertz, 1800 megahertz, 1900 megahertz, to 2000 megahertz, 2100, 2300, 2500, 3300, and 3500. So ano ba tong blue and red? So kapag yung red natin, these are in FDD, and yung blue natin is in TDD. So yung mga mobile operators natin, they buy these frequencies from the government. And dito then yung mga technologies natin that are existing to 4G, 5G, and so much, dito sila nagtatransmit ng mga frequencies natin. So kapag we have low frequencies, so mas greater yung coverage niya. Kapag high frequency naman, like pagdating dito sa 2100 to up to higher frequencies, they have greater bandwidth. So ano ba yung FDD? Ano ba yung TDD? Okay. So yung FDD, it stands for frequency division duplex. So it is a duplexing technique that separate frequency bands for uplink and downlink communication. So for instance, pag sinabi nating downlink, the base station transmit data to the user equipment. To the user equipment over a specific frequency band. Let's say 900 megahertz. So kapag sinabi naman ng uplink, ito yung user equipment to the base station. So simultaneously, the user equipment transmit data back to the base station using a different frequency band, let's say 1800 megahertz. So the uplink and the downlink transmissions are separated in frequency domain, which allows a simultaneous communication in both directions. So sabi ko nga, let's say so downlink base station to the user equipment, pag uplink naman is user equipment to the base station. Ayun. Next is we have the time division duplex or TDD. So paano naman kapag TDD? So it is a duplexing technique naman that are used in telecommunications to transmit and receive signals on the same frequency. So pag FTD, different frequency. Kapag TDD, the same frequency, but at different times. So TDD uses the same frequency for uplink and downlink, but separates them in time. So transmission alternates between two direction in specific time slots. So pagkaiba sila ng time. Kapag FTD, they are simultaneous. Nagde-differ lang sila sa frequency. Ayan. Okay, going back, recall lang and review. So we have, again, the wireless telecommunication system from user terminals. This is a more visual representation of the telecommunication system. So from the user terminal, these are connected to our RAN. Ito yung mga RAN natin, or yung mga cell sites natin. And these are connected to the core network via a backhaul. Ito yung different kinds of backhaul natin, the copper, fiber, microwave, satellites. Yan. Okay, here we go. So, pag-focus naman tayo with radio access network. So, what is a radio access network? So, a radio access network is responsible again for providing wireless connectivity required for our user equipments or mobile devices to connect to our core network so that we can access different services such as voice calling, messaging, and data services. So it includes a network of cell sites. So yung mga cell sites natin have different base station that communicates with mobile devices via airwaves. So, yung pinakang, um, yung RAN natin is part of a cellular network. So, yung it consists of nearest to your subscribers. So, you see it all around you. So, kapag nagbibiyahe lang tayo or just looking around, we can see different RANs that's been deployed. Also, location is widely distributed, kagaya nga ng sabi ko kanina, the designers, the planners, the engineers strategically place this RAN all over a geographic area. So it can be deployed in city, villages, highways, rurals, hills, beaches, malls, and offices to create a seamless coverage and mobility. Okay. So if you've been wondering kung paano tayo nakaka-make ng calls or texts while we're on the go or just traveling around. So yun nga is dahil sa RAN or sa radio access network. So kapag minsan even when I'm traveling especially kapag pumupunta ako ng office, I always look around, especially sa SLEC. I see a lot of this kind of RAN, and I always wonder um or always imagine um signals or waves that's been around. I know that's weird, but yeah, that's how I see things after knowing or after understanding how our telecommunication system works. Ayan. So, you can see a lot of these RANs in different locations. So, kapag nagbibiyahe kayo sa SLEX, marami kayong makikita ng mga towers, right? So, sa beaches too, kung nakapunta na kayo ng Boracay, makakakita rin kayo ng different towers, minsan sa hills or sa mga probinsya natin. Kapag nasa city naman kayo, like kapag nag-ride kayo ng MRT or LRT, you can see a lot of different RANs that's been deployed on different roof decks or rooftop of a building or a house. Kahit nasa loob kayo ng isang structure or building or mall, makakakita rin kayo ng RAN that is deployed already there. Ayan, eto. So RAN is technically all around us. So ayun, it makes us connected with each other. So but before moving forward with RAN, let me introduce you to the evolution of mobile communication. So kung iisipin niya, 'di ba, paano ba tayo um nag-start or um from having these cell phones or equipments that we are using right now, saan ba sila nagsimula? So ano ba yung meron tayo noon compare sa ngayon? So before, we have what we call the first generation mobile phone technology. So these kinds of technology uses analog signals to enable voice calling. So voice calling pa lang yung pwede nun. So these early mobile phones are were very large, expensive too, during those days, and it has a very limited network coverage. So kahit na may limitation siya, I think it lays as the foundation kung ano yung meron tayo ngayon. So all thanks to what we have before. Ayan. So these first generation of of phone technology are using AMPS, TACS, and NMT, or AMPS as Advanced Mobile Phone System, TACS Total Access Communication System, NMT Nordic Mobile Telephone System. So these are older mobile phone system that the first generation of mobile technology are using. Next we have is what we call the 2G. So a lot of my batchmates siguro, or yung mga older generation or mga millennials, Gen Z na abutan to. So these are year 1990, so it's already using GSM, or the Global System for Mobile Communication. So ito yung mga 3210 kung saan naglalaro pa tayo ng Space Impact, Snake, if if maaalala nyo. Ayan. So itong 2G na to was introduced, is using digital signaling, allowing for more efficient use of the radio spectrum so than yung una nating generation. Ayan. So remember, yung 2G natin is using GSM, Global System for Mobile Communication. Okay. Next is, ano yung next? 3G. 3G naman. So ito na yung mga pangmayayaman nung elementary ako kasi gumagamit sila ng QWERTY na keypad. Ayan. So itong third generation mobile communication natin was introduced in the early 2000s. So it brought a faster data speed, enabling more advanced services like mobile internet, video calls, and multimedia messaging. So eto, dito na yung nagka-introduction tayo with a better or faster data speed. So this is using UMTS as a system, or Universal Mobile Telecommunication System. Next naman we have is the fourth generation of mobile communication, which was introduced year 2010. So ito na yung mga Android natin, or LTE. So before yung mga Android natin hindi pa kasing gaganda ng mga nag-e-exist ng mga phones ngayon, pero still yung 4G natin enables a lot of advanced services. Nag-start na tayo with streaming videos, online gaming, mobile payments. It also makes way for us for the Internet of Things, or IoT, and other technologies that's been existing as of this moment. And now we have 5G technology, which was introduced year 2020. So this is using a new radio system, new generation na to. So yung 5G natin promises a faster, more capable kaysa dun sa 4G natin. Mas mataas na data speeds, which can be up to 100 times faster kaysa sa 4G natin. Wait, excuse me. That which will support a lot, or a massive number of devices at once. So ayan. So yung phone ko naka 5G capable na rin ako. Ayan. So sana kayo rin. Kasi mas mabilis talaga yung throughput kapag pag 5G, nung nakapag-test din ako before. Ayan. So ayun. After knowing the evolution of this mobile communication, let's run through the different names, RAN names in different generation. So meron din tayong iba-ibang RAN. Depends on each generation. So we have, if naririnig nyo na yung titag nating GRAN, UTRAN, EUTRAN, and GRAN. So yun yung iba-iba nating names for radio access network that are used in different generations of mobile communication. So ano ba to? So for 2G, which have services like voice calling and SMS, we call it the GERAN. So yung GERAN stands for GSM Edge Network Access Network. For 3G naman, we are using UTRAN or UMTS Terrestrial Radio Access Network. For 4G, we use EUTRAN, Evolve UMTS, Evolve na, UMTS Terrestrial Radio Access Network. And for 5G, um, which is our latest technology that's existing here in the Philippines, we call it the NGRAN or the Next Generation Radio Access Network. So these are the different names per generation of cellular mobile in the cellular mobile telecommunication. Pero these different RANs have the same working principle. And different names lang, pero same. Okay. So knowing what is a RAN, excuse me. Knowing what is a RAN, ngayon naman, i-break down natin kung ano-ano ba yung meron sa isang radio access network. Okay. So, yung RAN natin is first have a tower structure. So you can see on your screen. So this is the physical structure that supports the RAN components like antennas, yung mga cables natin. And these towers are designed to be sturdy and stable. Kasi kung hindi to sturdy and stable, baka ang dami ng gumuhong tower, di ba? So, kaya niyang mag-stand even with high winds and extreme weather conditions. Lalo na dito sa Pilipinas, very mabagyo. So, aside from the physical structure or the tower structure, we have what we call the antennas. So these antenna system is responsible for transmitting and receiving radio signals between our user equipments and the RAN components. So it is typically made up of multiple antennas that are placed at different heights on the tower structure to provide coverage to different areas. So iba-iba yan, iba-ibang size ng antenna, iba-iba rin yung um, sinuserve ng mga antenna natin, iba-ibang kinds of technology. So, aside from the antennas, we have what we call the RRU. So, yung RRU natin stands for Radio Remote Unit. So, ito naman is responsible for converting the radio signals received by the antenna into digital signals na pinoprocess naman ng BBU natin or ng baseband unit. This is more or typically located at the top of the tower or malapit dun sa mga antenna system natin. Next we have is syempre, yung mga cables natin. So, yung cables natin is one important component ng RAN system natin as these cables are used to connect the different components that the RAN has. So, ano ba yung mga different components na to? So, we already have the antenna, we have the RRU, also we have what we call is the BBU. So, yung BBU naman natin is responsible to process the digital signals coming from the RRU, ito yung mga RRU natin, and transmit these signals to the core network. So it is typically located at the bottom of the tower structure or nung mga towers natin or malapit dun sa mga cabinet or what we call the outer cabinet with power supply and a very good ventilation. So we also have ito yung mga cabinet natin. So we also have what we call the CPRI. So yung CPRI natin is a standard protocol used to transmit digital signals between the RRU and the BBU. So ini-ensure niya na yung mga signals natin are transmitted quickly and efficiently without any loss and degradation in quality. So, yun, CPRA yung ginagamit natin to connect our RU to the PBU. So, lastly, meron tayong tinatawag natin na transmission component ng isang RAN system natin. But in our example we have is the microwave antenna. So, itong transmission component natin includes equipment to transmit the digital signals from the BBU to our core network. So, sa example natin, microwave antenna, pero pwede rin siyang maging fiber optic equipment and other kinds of backhaul. So, ina-ensure niya that the signals are transmitted reliably and quickly over long distances. So, ito yung different components of a RAN system. We have again the antenna, the RRU, the cables that are used to connect the different components. We have the BBU or the baseband unit. We have also the outer cabinet and the backhaul or our transmission component ng isang RAN system natin. Ayan. So, isa-isahin natin that there are different visuals or example of a RAN or a tower or yung mga towers natin. So we have classification to ng tower is a four-legged self-support tower or the SST. So, pag nakakita kayo ng tower sa daan, ay, four-legged SST yan. Eh di brainy ka na nun. Joke lang. So, yung four-legged tower natin is generally constructed with different sizes or angles. So, nag-range siya from 45 meter to 106 meter. So, these structures are engineered and fabricated to accommodate heavy-duty loading imposed by attaching microwave dishes and mounting sectors antennas. So, itong mga four-legged SST natin, kaya niyang mag-handle ng a lot of components. So, kasi mabigat yun eh. Madami tayong ikinakabit sa isang tower. Pero kapag talagang madami talaga yung mga components, engineers goes to building for SST tower. So, yun nga. So, these towers are formulated to house various accessories. So, we have antenna brackets, lighting systems, climbing ladders, safety cage, cable ladder, utility-mounted poles. So, yung recommended height for this structure is 45 meters, 60 meters, 90 meters, 100 meters, which is suitable for single, mobile, or multiple operator usage as a strong site. So, aside from 4 SST, we also have what we call the 3-legged SST or the self-support tower. So, a lattice tower is freestanding and vertical tower with rectangular or triangular base. So, madalas mas marami ako nakikitang 3-legged SST around. So, itong mga tower na to can be favorable in places that involve mounting many panels or dish antennas. So, it can be used as electricity transmission, cell radio, or observation tower. Ayan. Ito yung example natin for our 3-legged self-support tower. Next we have is what we call the guide tower. So, guide siya kasi we're using guide wire. Guide wire yung tawag dyan. So, guide tower is a slender steel structure anchored by steel cables in the ground. And these are commonly seen in the tower because they provide greatest strength and very or most efficient and very easy to install. Next we have is the monopole tower. From the word itself is mono, so there's only one monopole tower. It's a simple single pole. So its elementary design reduces visual impact and is relatively simple to build. So tower developers favor this tower. So very easy to build daw. Ayan. So ito yung itsura ng mga monopole towers natin. Next is, saan pa ba? We have the rooftops. So, kapag yun kagaya ng sabi ko kanina, kapag nagta-travel ako or sumasakay ako ng MRT or LRT, ang dami kong nakikitang RAN sa mga rooftops natin. So, yung mga RAN na nasa rooftop natin or this is RTT is narrow, 4-leg angular up to 12 meter and very light. So these are slim. Yung pole natin, nag-height lang siya or nag-range lang siya from 3 to 6 meters. Tapos, yung rooftop bipods naman natin is height ranging from 3 meters to 12 meters and are usually for mounting 3 to 4 antenna panels. So, ayan. So, kung i-observe nyo, yung mga rooftop RAN natin, ganito yun, yung mga itsura nila. Next is wall mount sites. So kapag naman yung isa kong example nito is sa Makati, marami rin akong nakikitang mga wall mounted RAN or sites. So ito is light cell site installed in the walls, on the walls of buildings na may mga brackets. Madalas kakulay sila ng mga buildings. So hindi sila rin ganun kapansinin. Next is cell site on wheels. So, etong mga cell sites on wheels naman are telecom infrastructure placed on trailers, approved for road use and towed by heavy goods vehicles for loads up to 3,500 kilograms. So, usually, ginagamit natin tong mga cell site on wheels kapag may mga events like concerts and other big events na kailangan ng ano, ng na maraming pagse-servan or maraming users pero hindi kayang pag-servan ng mga nag-e-exist na mga um network providers. So nagde-deploy sila ng mga RAN especially kapag mas massive na or marami na talagang tao especially sa mga concert and other events sa mga open areas. Next we have is what we call the camouflage sites. So camouflage from the word itself. So, naka-camouflage yung mga cell sites natin. So, for example here, we have the water tower or water tower. So, nakakita na rin ako nito. Nasa biyahe lang din ako. So, this structure is conducive financially to communication company because the company does not have to spend thousands of dollars on building a new tower structure. Siyempre, kinakabit na lang to dun sa mga nag-exist na water tower natin. So, companies usually negotiate rental prices with the tower companies or the wireless carrier to allow companies to put their equipment on top of their water towers. So, ayun, nini-negotiate to na may bayad syempre. So, win-win lang to for both the operator and yung owner ng mga water towers natin. Same goes, we have what we call the stealth tower from the word stealth. So, naka-disguise yung mga cell site natin, minsan mga puno, ayan. Para hindi siya ganun kahalata, para ano pa rin yung aesthetic nung lugar. Usually kapag magaganda yung mga lugar na to or sa mga pasyalan, gumagamit tayo ng mga stealth tower. Ayan. So, naka-camouflage siya. Next we have is what we call the in-building solution. So, is an indoor DAS or in-building wireless system. So, kung makakakita kayo sa mga malls ng mga antennas na kagaya nito, sa mga nasa office, na nasa building, mga hotels, and other structures, makakita kayo ng mga ganitong kinds of antennas. So, eto, part yan ng RAN na nagbibigay ng network coverage sa atin kapag nasa loob tayo ng isang building. So, ito yung scenario kapag indoor yung system natin. So, for example, we have the different equipments of the RAN. So, we also have RRU, PBU, cabinet, battery unit. Minsan nasa loob siya ng isang room or isang area sa isang building. Pwedeng nasa parking, pwedeng kung meron silang designated na radio room, dun nilalagay yung mga equipments na 'to. Tapos yung mga equipments na 'to is, yung mga antena na nakita niyo kanina sa pictures are connected dun sa pinakang, different RAN equipments natin, and gumagamit tayo ng, different cables, different splitters para ma-deploy natin or para magkaroon ng coverage yung mga users sa loob ng isang building. Ayan. At hindi rin sila basta-basta nilalagay sa isang building. Dinidesign din 'to. It's strategically planned din kung saan ini-install yung mga antena sa loob nito, sa loob ng mga buildings. Ayan. So ganito yung itsura or parang visual ng isang indoor or IBS, indoor building solution. Ayan. So nagbibigay sila ng signal sa loob ng building. Next we have is the small cell or what we call pickle cell sites. So this kind of cell site is connected by fiber optic cable and mounted to an already made structure like a light or a utility pole. So makakita rin kayo nito sa mga urban areas natin or mga lugar kung saan marami ring tao pero hindi dapat aesthetic pa rin. So this makes them more discreet while bringing them closer to smartphones and other devices. So like a tower or small cell poles communicate wirelessly over radio waves and then send signals to the internet and phone system. So kagaya lang din to ng mga towers natin, ganun lang din yung purpose ng mga small cell or picocell sites natin. So nagbibigay din sila ng network coverage, especially dun sa mga streets, sa mga cities, nakakakita rin ako nito. Kung mag-o-observe lang kayo kapag namamasyal kayo, Makati area, may mga small cell or picocell na naka-deploy dun. So lastly, we have the portable or the private cell site. So portable siya. So Singtel release a portable cell site to serve in disaster situations that are small enough to fit into a suitcase. So usually ginagamit to with disaster situations. So giving first responders another communication tool when regular communication channels are offline. So yan yung portable and private cell sites natin. Moving forward, ano ba yung mga equipment natin that comes from our traditional vendors? So first is we have what we call the RRU. So again, ano nga ba yung RRU natin? So yung RRU natin is a device that helps your phone, the user equipment, connect to the cell tower or yung RAN natin. Your phone connects to the cell. It's usually placed malapit nga dun sa mga antennas natin, dun 'di ba kanina dun sa tower structure natin. Yung RRU natin, usually nilalagay siya kung saan malapit dun sa mga antenna natin. And ano ba yung pinakang main job ng RRU natin? First is it converts signal. So yung digital signals natin from the network and converts them into to radio waves or analog signals that can travel through via airwaves to reach our phone. So vice versa then. So converting the radio waves from your phone back into digital signals. So it also amplifies the signals. So it boosts the strength ng mga radio signals natin. So they can travel long distances, ensuring that users get good mobile coverage and data speeds. So kung ilalagay natin yung mga RRU natin closer to the antennas. So, yung signal quality natin improves and the network can handle more users with faster, more reliable connection. So, it is one of the key parts of our mobile networks to have more efficient and scalable for high demand areas like sa mga cities natin. So aside from the RRU, we also have the BBU. So ano naman yung BBU natin? Wait. So ito yung BBU natin. So the baseband unit is responsible for processing the baseband signals that is placed in the equipment room and connected with RRU via an optical fiber. So this is one of the essential component in a mobile network, usually found at the base of the cell tower or in a cabinet or as a centralized location. So, ano ba yung pina-perform niyang mga or yung mga functions niya? So, one is it's signal processing and the other is control function. So, yung BBU natin, pina-process niya yung digital data that comes from the core network and prepares it to be sent out as a signal through the RRU and the antennas. It also takes yung signals natin from our mobile devices, converts them back into digital data and sends them to the core network. So it also manages kung paano nag-interact yung network natin with our phones and tablets or other user equipment. So it decides which user get access to different frequencies, handles handovers between different towers kapag when we're on the go or moving, and manages the overall traffic in a network. So in short, yung BBU natin is the brain of the cell tower system. Samantalang yung RRU natin kanina, it's more of like the hands which handles the physical transmission of the signals. So, kapag pinagsama natin tong dalawa, we can get a more reliable connection and faster data speeds. So, aside from these two, ano pa ba yung isa sa equipments that we're using from our traditional vendors? So, the last one is what we call the CPRI or the Common Public Radio Interface. So, kanina sabi ko, it is a standard protocol used in mobile networks to connect different parts of a cell tower system. To easily understand it, yung BBU natin is, sabi ko nga, the brain of the system, kung saan tayo nagpa-process ng mga signal. Yung RRU natin naman is located near yung sa antenna natin, which handles sending and receiving signals to and from the mobile devices. Yung CPRI natin will stand as the language or the communication link that allows the BBU and the RRU to talk to each other. So it transmit the digital data between the units, like the instructions for what frequencies to use, how to process signals. So kung gagamit tayong CPRI, yung mobile operators can place the BBU far away from the antenna while still ensuring fast, reliable communications. And this is very important for things like the location, the costing, and making our network or the network more efficient. So that's how or what the CPRI it functions. Ayan. So moving forward, or the last part of this whole session, we have is the RAN and OSI layer. So the RAN system is divided into different layers sa OSI layer natin. So each layer is responsible for different aspect ng buong system natin. So one common way for us to understand visually or conceptualize this layer is using the OSI or the Open System Interconnection model. So yung OSI natin is a conceptual framework that used to understand and standardize how different networking system communicate with each other. Ayan. So we have 7 layers for OSI. We have the application layer, the presentation layer, the session layer, the transport layer, the network layer, the data link layer, and the physical layer. So these are very familiar, especially sa mga ECEs natin. So kung iisipin, these layers have different function. And for to easily understand, this is just like a step-by-step process how on how we send and receive data across one network. So yung OSI model nga natin is a set of concepts that describe and standardize how a computer or telecommunication system communicates, regardless of how it is built or what technology it uses. So ano-ano ba yung function ng different OSI layer natin? So first we have is the physical layer here. The physical layer. So it deals with the actual hardware. So physical to. Physical hardware to. Part nung pinakang network natin. So ano ba yung mga example nito? Syempre yung example nito is like yung cables, the switches, or how signals are transmitted over a physical medium. So for example, we have the Ethernet cables or Wi-Fi signals that physically connect the different devices. Next we have is the data link layer. So ano ba yung ginagawa ng data link layer natin? So this one naman is responsible for ensuring that data is transferred efficiently or error-free between two connected nodes or devices. So it gives us a more reliable network. So it packages yung mga frames natin and controls how the device on the same network share over a physical medium. So ano ba yung example ng data link layer natin? One example of it is a MAC address which is ginagamit natin with internet, Ethernet or Wi-Fi. So it helps yung mga devices natin to identify each other on the same network. Next we have is the network layer. So ano ba yung meron sa network layer natin? So sa network layer naman natin, it is more on the routing. So it decides kung saan yung pinakang best way to route data from the source to the destination across different multiple networks. It all usually using logical addresses like yung mga IP addresses natin. So for example, yung routers direct data packets between different networks. So paano ba ito nangyayari? Gumagamit tayo ng different IP addresses. Next, we have is the fourth is transport layer. So ano ba yung meron sa transport layer naman natin? So yung transport layer natin, ine-ensure naman niya na yung data natin is being sent reliably. So it breaks our data into smaller packets and sends them to the destination and reassembles them into so it can handles different functions like error checking and flow control. So example nito yung TCP natin or transmission control protocol. So it ensures na yung data natin is dumadating or nare-receive natin correctly and accurately. On the fifth layer we have is what we call the session layer. So ano ba yung meron sa session layer natin? So sa session layer naman natin, this is where we establish, manage, and terminates communication session between two devices. So sa session layer, it ensures na yung connection is well maintained and synchronized. So for example, we're doing this video conferencing. Yung session layer natin, and it keeps the call connected. So that is the function of the session layer. So second to the last we have is the presentation layer. So yung presentation layer natin, it translate the data between the application layer and the network. So it handles different functions like data encryption, compression, conversion that ensures different systems can understand each other. So for example is we have different file formats like JPEG for images, MP3 for audio, and other different file formats. Pag naman mga encryption, we have HTTP. So dito 'yung nangyayari lahat sa pinakang presentation layer natin. And of course, lastly, we have what we call the application layer. So ano 'yung meron sa application layer natin? So this layer naman is closest to the user, or these are the layer wherein we interact with the network. So it provides the interface for the user to interact with the network services. So ano ba 'yung mga example nito? We have web browsers which use HTTP, emailing which use SMTP, different kinds of file transfer application or FTP. So itong mga kinds of of application, dito sila nag-ooperate sa application layer natin. So I hope nagkaroon kayo ng grasp kung paano ba nagwo-work yung different layers natin. So ayun. So we have physical layer, data link layer, network layer, transport layer, session layer, presentation layer, and application layer. So, nung nagre-review ako or nung estudyante pa ako, gumagamit din tayo ng different layer mnemonics para mabilis nating matandaan tong 7 layers na 'to. So we have all people seem to need data processing, pero ako nun ang ginagamit ko is ang pulis sa tulay na dapa. There's a lot more, depende na sa inyo kung ano yung minana niyo sa mga ninuno niyo. Ayun, so yun yung ano, namana ko sa mga professors and sa mga higher year namin. So ayan, so ano ba yung ano, in an OSI layer mapping in RAN, so meron yung radio RAN natin is nag-ooperate with in 3 layers. So we have the physical data link and the network layer. So this is done by 2 main units. So the RRU and the baseband unit. Okay. So let's map these layers sa different components natin of the RAN system. So again, we have the physical, the data link, and the network. So in the physical layer sa isang RAN system, so the physical layer is more on responsible again for the transmission and reception of raw data over a physical medium. So these are example of the antenna systems, the tower structures, RRU cables, are components that fall into this layer. So dito, this is where the radio signals are transmitted and received between the mobile devices and the network. So yun yung nangyayari sa physical layer natin. Next one is we have the data link layer. So in a data link layer naman in the RAN system, it is again responsible for reliable transmission of the data over a shared physical medium. So this layer includes the RRU, which communicates with mobile devices over the airwaves, and the BBU, which processes demand and manages the data transmitted by the RRU. So ayun. Next is we have lastly is the network layer. So in the network layer naman in a RAN system, it is responsible for routing our data between the different devices in a network. So it use different protocols such as the IP and the MPLS. So in this layer, it also includes the network gateways, what we call the network gateway. So ano ba yung ginagawa ng gateways natin? So yung gateways manages how our data is routed between the RAN and the core network. So that's what's happening um in a RAN system. So if we map the OSI model to the different components in a RAM system, mas mabilis nating maiintindihan yung role ng iba-ibang layer in an OSI layer, in an OSI model, or and how they all work together so that we can have reliable and more efficient wireless connectivity for our user equipments. So these basic concept, or these model is a very essential knowledge for us, or the engineers or different telecommunication professionals who work with um these systems to understand these systems more. So yun, dito natin ginagamit yung OSI model. Ayan. So this is the end of my session. So we have different key learning points for this. We have the RAN, which means the radio access network. So yung RAN natin is part of a cellular mobile network that gives mobile coverage. So we have three main parts of our telecommunication system, which is the user terminal or the user equipments, or yung mga ginagamit nating um mobile devices. We also have the radio access network, or the RAN, or the cell site. And lastly, we have is the core network. There are also different names for different RANs in each generation. Iba-iba lang sila ng pangalan, pero they are working on the same principle, with the same principle. So we have JRAN for 2G, UTRAN for 3G, EUTRAN for 4G, and GRAN for 5G. So radio access networks may differ in physical structures but have the same working principles. Ayan, 'di ba? Kanina we have different structures. We have four-legged SST, three-legged SST, and so much and so forth. Pero the same lang naman yung functions nila. So the main components of a RAN are an antenna system, RRU, BBU, and the interface. And different RAN generation has different but working network architectures. And the OSI model, or the Open System Interconnection Model, is a set of concepts that describe and standardize how a computer or telecommunication system communicates, regardless of how it is built or what technology it uses.